Hello, everyone, and thanks for joining us today. On behalf of the Environmental Finance Center Network, welcome to our webinar today on GIS field data collection. My name is Tess Clark from the Syracuse University Environmental Finance Center, and I'm super excited you're all here for this training. GIS is one of our most highly requested topics, and I'm thrilled that our colleagues from the EFC at Sacramento State have put this together. Before we get started, there are a few logistics to keep in mind. First, everyone will be on mute to ensure audio quality. If you have a question, just type it into the GoToWebinar question dialog box anytime throughout the session to be queued up and asked for the presenter. We will be holding the questions until the end. You will be receiving a follow-up email that includes a link to all the materials and any other information that you might need, including a recording and a survey. And for folks interested in the slides, they are already available to you in the handout section on your GoToWebinar panel. This webinar has not been submitted to licensing agencies for pre-approval of continuing education credit. We are happy to provide certificates to registered attendees, but cannot guarantee that you will be able to get a specific PDH or CEU. In order to receive a certificate, you must attend the entire session, and you must register and attend using your real name and a unique email address. Group viewing credit is not available. Certificates will be sent via email within 30 days and are for your personal records. Again, we can't guarantee that our webinars will meet any specific PDH requirements. Now for a little bit about our network. The Environmental Finance Center Network provides training and technical assistance to small public water systems in all U.S. states and territories to help local systems achieve their managerial and financial goals. We are able to do this at no cost to you through our Smart Management for Small Water Systems program, funded through a cooperative agreement with the Environmental Protection Agency. Check the chat box for a link to our TA request form, and you should be able to fill that out. And here you can see the various centers that make up our Environmental Finance Center network. You can see that the centers and partner organizations are spread across the country. We work together to create solutions to difficult how-to-pay issues of environmental protection and improvement. And on that note, I'd like to introduce our speakers for today's training. Please welcome John Heltzel and Scott Meyer from the Environmental Finance Center at Sacramento State's Office of Water Programs. So Scott, I will now turn things over to you.
I think John's going first.
Oh, John, I'm sorry about that, John.
No problem. All right, good morning or good afternoon, depending on where you're joining from. Thank you, Tess, for that introduction. Again, my name is John Heltzel, and I'm a research engineer with the Office of Water Programs at Sacramento State University. And I'll be presenting today with my colleague, Scott Meyer, who is a geologist and GIS specialist. And we'll be talking today about field data collection, specifically using a Trimble GPS unit. We will also be discussing some other units that you can potentially use, but we have the most experience with the Trimble unit. Just a little bit of background for you all that are listening. We've collected field data for California state parks, specifically for stormwater infrastructure, as well as water and wastewater utilities. And so we hope that regardless of whatever unit that you may be using, some of the lessons learned as well as the methodology that we'll be talking about will be useful for your application. And so just a quick introduction for some of the topics that we'll be discussing. First, pre-data collection planning in the office. Scott will be going over some of that initial planning effort that's required. And then I'll be discussing data collection in the field. And then lastly, I'll turn it back over to Scott to discuss post-processing data once you're back in the office. And at the end of this presentation, we're hoping to leave some time for a Q&A session. as well as any recommended future topics. So if there's something that we don't cover, or there's some additional topics that you'd like included in a future webinar, then please take the opportunity to provide us with those suggestions. And we have a poll question first here before I turn it over to Scott. Do you currently use GIS in work related to water utility management?
And I'll just jump in here and let you know, Scott, John, we have about 42% of people responding so far. And for other folks on the call that maybe can't see the poll, we're encouraging people to tell us if you use GIS often, sometimes, or never. I'm going to give you 3 more seconds to get your responses in, and I'm closing the poll in 3, 2, and 1. And as for our results, 47%, the majority of folks said they use GIS sometimes. 31% said often, and 22% said never. So there's a very even spread almost between often and never.
Okay, great. Thank you for sharing that, Tess. And hopefully, regardless of whichever category you're in, you'll be able to take something away from this webinar that could be useful for your particular application. So I'm going to go ahead and turn it over to Scott now to discuss pre-data collection planning.
Hi everybody. Let's see. That was John in the last picture there holding the Trimble GIS unit. And let's see. Okay, so before you go out and start purchasing the equipment, which can be really expensive and take a lot of time, you really need to know exactly what you're going to collect beforehand so you can make the right choice about what unit and what software you want to use. Possible reasons you're doing this are assets management, possible maintenance in the future. Maybe you have a regulatory requirement. That's one of the things we were doing for state parks. And it's also possible you may be collecting this data for doing computer modeling. That's one of the requirements we actually had, and that really did what we needed to collect and really influence which unit we used because of that. And all these, whether it's asset management or maintenance or requirements, there'll be a lot of overlap, but in some cases, there'll be something you specifically need for one of those cases. Next slide, please. So there's 2 basic ways you can approach this. You can go with the bigger, more expensive approach, which is to get a GPS data logger and use desktop GIS, or you can go for a simpler, usually cheaper approach to use a cell phone or a tablet and an app on those devices. We went with the Trimble Geo7X device, which I'll be talking about mostly here because that's what we're experienced with. So that's the that kind of bright yellow safety yellow device there in the lower right-hand corner, a ruggedized device. There's actually 2 pieces of software you can have on it. Trimble makes the TerraSync software, which we decided to use, but there's also the Esri ArcPad software you could use as well. So if you use a lot of Esri products, maybe you're interested in that. We went back and forth on which to use. We decided to use TerraSync because it's easier to learn and to set up. ArcPad, more difficult to set up, but is apparently better for doing updates. If you're doing lots of updates, you may want to look at ArcPad, but from our experience, we've seen most people have used the TerraSync. So that's what we'd be using in the field. In the office, you're going to need some GIS software. You can use ArcMap or another Esri product, or QGIS is really good freeware out there, open source software. QGIS, actually a very good GIS tool if you're looking for something that's maybe cheaper than ArcMap. Of course, you can always use the cell phone apps, and depending on your case, you might want to use something like the CUPS mobile apps with this freeware. There, you could use something like ArcGIS Collector to gather this data using a cell phone or a tablet. Or you might use one of those commercial apps that have some of these are actually pre-set up for water systems. That could be another course you take depending on your needs. Next slide, please. So I just want to go really quick over the comparisons between these systems. So over on the left, we have these different factors. In the middle is using the data logger and desktop GIS. And on the right is the phone and so the initial cost, if you're using something like the Trimble, it's expensive. The one unit we're using, it costs about as much as a small car. So it's quite a investment there. But if you want to go for a less expensive route, you can rent it. You don't need this full time probably. You can get training and rent these, less expensive way to go. If you're using a phone or an app, the initial costs are generally much, much lower. But then there's also monthly costs. If you're buying the device or renting it, well, maybe the initial monthly costs there if you're renting, but none. If you're using an app and going through a service, just be aware there may be a monthly charge you have to be paying every time just to be able to keep your data. And then there's the ease of initial setup. The Trimble units are more capable, but they are more involved. So it's going to take longer to get everything set up. And the phones being apps, they're really made to be much simpler. Field crew training. There's a lot more to work with the Trimble GPS because it's got the external antenna and the pole you're working with there. So moderate training there, easier with the apps. But training isn't too bad. You can get field crews trained easily within a day. And then the data you're collecting, how customizable is it? Really incredibly customizable with the Trimble unit. Still pretty customizable with the phones and apps, depending on the system you're using. But the Trimble, I'll show you, can do quite a bit. A lot of people don't think about this. Data storage, who's storing it? With the Trimble, and if you're using desktop GIS, you'll be in charge of your data. But this could be a drawback to people who aren't experienced with databases and GIS. And sometimes it's easier to have somebody else taking care of the data for you. And if you're using those apps or some of those commercial apps, the data management is done by others. And that can be a plus or a minus there. If you've got sensitive information, maybe you don't want that information out there. Or one of the problems is if you're using a commercial app, you can never be guaranteed that the company is going to stay in business, and you got the potential for losing your app or your data. So hopefully that won't happen, but that possibility is out there. That's why I like to have the data being stored by myself. Let's see, then there's GPS accuracy. The Trimble units are very, very accurate. For our needs, we actually needed to model stormwater going through the storm drains. So we needed very precise data. And we went with the unit that could go, let's see, less than half an inch of accuracy. So we can really nail down the of these devices. Cell phones, 10 feet accuracy if you're good, which for most applications that's going to be good enough. If you need to know where a manhole is or a valve, you probably don't need to know it exactly. Within 10 feet, you can find it again. So that's got its place. But elevation data was really important for us because we were trying to model the flow through pipes. We need elevation data, so we need to know the inverts of these pipes and know what the elevations were. And the rule of thumb is that you take your horizontal accuracy and multiply it by 5. So if you got less than half an inch with the Trimble unit, that means you're going to be in a couple units, or excuse me, a couple inches of accuracy vertically. So that's pretty good for our purposes. That's going to be close enough. But if you're 10 feet with the phone, that means you got 50 feet of accuracy for elevation data with a cell phone. It's probably not going to be very useful for you. And the last one here is, do you need cell phone coverage for these units? With the Trimble, no, you don't need a cell phone at all. Depending on the system you went with, which app, some of those do need a cell coverage. So they work really well in urban environments, but if you start getting out there in rural areas, they may not work as well. A lot of these can work without the being hooked to a network, but they really are trying to store their data on some server that's far away from you, and that can just lead to some limitations. Next slide, please. So we got a poll here for tests. If you do this, do you have prior experience with GIS or Trimble GPS units?
Yeah, so we're going to just give you a few seconds to tell us yes or no on whether you have prior experience with GIS or Trimble GPS units. I can see that about 70% of folks have submitted a response, so I'm just going to give you 3 more seconds. So I'll close the poll in 3, 2, and 1. And as for our results, yeah, a good amount.
Okay, so yes. So I've set this up so this should be useful for anybody with any level of experience. If you are actually really know Trimble GPS units or really into GIS, hopefully I'll have some tips here that can help you out, maybe be useful. And I've tried to make it introductory as well. So if you don't know anything about these units, you still will get something out of this. So hopefully this will work out for everybody. Okay, so next I wanted to talk about data dictionaries, which is, I always thought this was a confusing term. What does that mean? This is really used to organize and store the data that you're collecting in the field. Practically, what it really turns out to be, it's the customizable user interface that you will build, in this case, for the Trimble units. This is what we work with. I'm going to talk about the data dictionary you can build with the TerraSync software. So this, if you do it right, will be a user interface that will walk the field crews through collecting their data. And it's, by walking through, it's actually really nice because you, depending on what choices the field crews pick for different inputs, the feature information that it's going to try to gather will change. Like this sample input here for a storm drain. I was talking about the pipe over here on the left. If the pipe shape is circular, it will only query the user in the field there for the height. But if you were to say the pipe shape is a box shape, then it will add the width as well. So this is actually pretty nice. And this way you're not showing extra information to the field crews. And as things change in the field, they find different parameters that they need to collect, is exposed or not. Like up the top here, does the storm drain has a drop inlet? That's unchecked right now. If that was checked, a whole other section would open up and ask for information about the grades, what's the grate material made out of? Is it steel? Is it galvanized? Dimensions would all show up there. But if there's no drop inlet, you don't want the field crews to accidentally filling out information that's not needed because it doesn't really exist. It just doesn't show up at all. So that's what's really nice about the data dictionaries. And I actually thought they're kind of fun to work with. And takes a little bit to learn, and it'll be an iterative process, but these are really useful. Next slide, please. Just a few tips if you're making a data dictionary. Try to make all the inputs a checkbox, a drop down, or radio buttons. Radio buttons are those circles there. You can only click one at a time. If you click box, the circular portion will get unselected, and it'll just say box. Check boxes, you can click on and off as many as you want. So those are all really useful. And you've got to think about what the field crews are using. These are kind of small handheld units that you're trying to use in bright sunlight. The screens here are actually pretty bright, so they're pretty visible, but they're using a stylus to try to input this data. And text is a lot harder for field crews to input in the field. Sometimes you'll need text. It slows things down. But if you can make it so as possible, the field crews are going to be way more efficient. For the examples here, I showed that there's text box there for the heights, because we were doing state parks and these things were all made at different times, and we had no idea what types of pipes and shapes of the pipes to be out there. Actually, we had a lot more complicated pipe shapes out there. You can even find oval shapes out there. I just kept it simple here. But the field crews have to type it in here. And anytime you're typing in, you have to worry about typos. Those can happen. You get an extra 0, they leave off a 1, and it's just a problem. So if you were setting this up for a water system, you might know that you only have 5 types of pipes out there. Maybe you've got only 6-inch pipes, 12-inch, or 36-inch pipes there. You could set it up so they just have to click on that. But you could also set up an other button. And this is really useful for a lot of these fields, is to just have something that says other. And as soon as you click on other, then a text box opens up, and then you can put in the other if you get an oddball shaped pipe. So that's there. So like I said, text should only be used as a last resort, but it'll be a last resort a lot of the times. And you always should have a note sections at the very end. So just if something's weird about say it's a pipe or a valve or whatever you're getting information on, you should have a note section there just so you can put that information in there. But you've got to make sure people aren't putting valuable data in there. You can't query and do really much with notes, because people try to store things in notes that really should be part of the data dictionary. If you see a lot of information being stored on notes, that means you probably means you need to update the data dictionary and make that a field. Let's say people are leaving lots of notes about corrosion or something like that. Then that should be a question in the data dictionary. Okay, next please. Oh, another tip that I found really useful. People using GIS and databases already know this, but you need a unique ID for all the features you are collecting. Whether it's a pipe or a valve or anything you're collecting out there, it has to have a unique ID. And the software in the Trimble will do this for you, but it's not great. When you start collecting out there, if you've got a valve, you'll start off and say, you can do things like say, this is valve 1, valve 2, valve 3. That's great. But if you go back out in the field and start collecting again, it's going to start over again and start collecting valve 1, valve 2, valve 3. When you start combining this together, now you've got duplicate values, which really can be a problem. And they really do tend to almost like poison a database or a GIS file, because now you start getting duplicate features in there. So what we did, all I have to do is append something to the end. So we did have things like valve 1A, valve 1B. Valve B just means you went out there a second time, or there was many reasons we were out there. Just making sure everything has a unique ID will be just make your lives much simpler in the future. You really do want to get all the data on the first round. This is why it's so important to go over what your needs are early on to make sure all that information gets into the data dictionary. Because updates are difficult. They're doable. They can be done, but it's harder. So if you can get everything the first round out there, you're going to be much better off. And photos are great. Take more photos than you think you need. Just keep taking photos. The nice thing about the Trimble unit and phones, they've got cameras built right into them. So take pictures, and they can get stored right into the GIS databases. It's very handy, and a lot of questions can be answered. Maybe you have a question, maybe you didn't even think about something. Sometimes that information is stored in a photo, and you don't have to go back out there in the field. That can save you a lot of time. Oh, I do want to point out that anytime you are creating a data dictionary, you should always have what's called a miscellaneous point, lines, or areas. These are just 3 ways you can store data as points, lines, or 2-dimensional areas out there. You always need this just in case you've run into something unexpected. So they're really useful, but they can be a little bit dangerous, because you don't want field crews using this unless they find something unexpected. Like maybe they find a patch of poison oak that they want to warn future field crews about, or maybe there's a valve in that poison oak and they can't get there, so they use an area, say this area is poison oak. So that's good for that, for something that's unexpected. But you may need to make sure they're not putting actual real valuable data in these miscellaneous points. And if say you run into a lot of say poison oak, well, you should probably make that a feature, just like pipes and valves that you could add into your database. So it's good for kind of one-offs. Next slide, please. Oh, preloading data is really useful for everybody. This just means before the field crews go out, you go into GIS and load in, say, buildings. Buildings are actually a real pain to collect in the field. You would think something as big as a building would be pretty simple to collect in the field, but there's there are 4 points. That means you got to go around instead of just grabbing 1 point. There are at least 4 points. Complicated buildings can be, well, a lot more points, obviously. Interesting thing that John will be talking about, as you get closer to buildings, you lose half the sky. You lose half of your satellites that you can view. So if you get next to a building and try to take a point on a corner there, you'll find your accuracy just gets terrible. And when you look at your building afterwards, it's going to look like this weird rhombus if you're lucky. It might even have a star shape. So if you can do the buildings beforehand in GIS, and then the field crews can then fill in the data later, that really helps. Roads you might want to put in, say private roads. There's also, you can get roads from other layers out there, and maybe you want to use OpenStreetMaps. You can probably don't have to do the roads yourself. Also, some of the utilities out there can be visible. If you, the aerial photography you can get can be really really detailed. So maybe you're trying to find water meters and trying to go to everybody's house and find water meters. Sometimes you can see this pretty easily from aerial photography, or you can use things like Google Street View to find water meters. Doing things like that, especially if you don't care about really high accuracy, if you just know this water meters within a few feet of here, you can click on that, and then the field crews can go out there and get any more information when they're out there. So that's just nice to preload that data. It'll save everybody a lot of time. And this over on the right here is just showing some of the data we collected for a state park. Okay, next slide. Now here's a little trick we found that was useful. This was giving the field crews printed maps. So what this is a lot of notes here. This was 8.5 by 11. 11 by 17 sheets we would print up and give to the field crews with all the preloaded data on there. So like the roads and the buildings, and this was for state parks who are interested in parking lots and where the water is going, and sent this out to the field crews. And this was really useful. There is some data out there that's really hard to put into a GIS unit. In this case, it's flow lines. We needed to know exactly where all the stormwater is going, so the field crews would draw those blue arrows on there to show the direction of stormwater flow. If you tried to put that in a GPS unit, that could take you hours of just walking and adding those lines in there, or it just takes a few minutes for the field crews to sketch this there. So that's just some information just doesn't really fit into GIS easily. Plus, they're able to take notes here. But the really important thing, takeaway this is really useful, but it can be dangerous in case field crews start putting data onto the notes, but not getting it into the data logger. So you need to make sure the field crews are, if they get it on here, it also goes in the data loggers. Our field crews are really good about this. Oh, another thing, this lets you put notes in areas that are inaccessible. It's kind of hard to see, but there's an area here that's a cliff. Yeah, right through there, that's actually a cliff. And we don't want people going up and down that cliff. We want to keep our field crews safe. So they were able to sketch in what they could see over there without actually having to access it. So this was useful. Yeah, this is California state parks. There were lots of cliffs, so having maps actually really kept field crews out of areas that were dangerous. Okay, so we're on to John now.
Thank you, Scott. So just to continue on, so we'll be talking about data collection in the field now. So first off, our office actually put together a field guide with the goal of helping familiarize staff with whatever equipment you're going to be using. Particularly if you're renting a GPS unit, you really want to maximize your time out in the field. And if your first time out, you're trying to learn the equipment as well as collect the data, the likelihood of making errors is going to increase, and your time just isn't going to be used as effectively. So it's really important just to try to familiarize staff with the equipment, discuss in that pre-planning effort that Scott mentioned your methodology for collecting this information, and just try to have some type of a game plan before you head out into the field. And so I'm going to talk now a little bit about the feature types that you can collect. So the first and probably most common is going to be point features. For a small water system, these are going to include your water meters, your valves, your pressure relief valves. And I want to talk a little bit about data logging accuracy when you're collecting these points. So this is actually a screenshot taken from the Trimble GPS unit. You'll see an outline of a satellite in the upper left with the number 18. So that 18 denotes how many satellites are being received by the GPS unit. And you'll see a number in the upper right-hand corner, 28-inch. So that 28 denotes the accuracy that you're potentially receiving with your GPS. And when you're logging a point with the Trimble, every second the GPS is recording a position. And the more satellites that you have logged and the more points that you take, let's say you stand there for 30 seconds or so, that accuracy is going to increase. And you might see that 28-inch reduce down to 2 or 3 inches if you have good reception and a clear line of sight of the sky. So just a little bit of a discussion there on data logging accuracy. A sample data dictionary that Scott talked about for point features may include, the size of a water meter, type, serial number could be another characteristic. Age, I have highlighted here in particular, since if you're going to be using this information for asset management, age is going to be critical for planning, maintenance, or any potential replacement projects. Potentially manufacturer notes and photos, again, also very critical when you're collecting this data out in the field. The next feature type are going to be line features. So for a small water system, these will be your water lines, or maybe your system has canals and ditches. There's two main ways to collect line features. One of those being to simply walk along a water line or canal or ditch, and the GPS will log one location every second that you're walking along that section. Now, you're not going to have as good of accuracy with that methodology, and that method that I just mentioned would be like logging from vertex 2 to vertex 3 in that figure that I have on this slide. The other way that you can collect line features is to collect two vertices. So let's say you collect a point at vertex 3 and a point at vertex 4. The GPS will automatically connect those 2 points with a straight line, and typically that's going to be much more accurate. Your lines are going to be straighter, and oftentimes you won't have to go back and correct. The problem with walking along the line, a water line or a ditch, is that sometimes you might have interference. Your accuracy may vary as you're traveling along that course, so it's really difficult to get straight lines in that circumstance. And again, I have a sample data dictionary here for line features. It looks similar. Size, material type, age, condition may be another characteristic that you might want to collect. Depth, if known, may be another. And again, notes and photos. And then the last feature collection type that I'm going to touch on are area features. So these will include your buildings. You might be collecting property boundaries, paved areas. As Scott mentioned in his section, some of these you may want to automatically preload into the GPS, and that way field crews can just go ahead and update those as necessary. Once you're out in the field, that can be easier than going out and collecting them manually with the GPS unit. And I wanted to just talk about some unique features of the Trimble unit that may save time out in the field. So one being a nested point feature. And what this means is that you could be, I have a scenario outlined here where you're logging a canal, and you may come across a customer service. That's a point feature that you want to collect. So as you're collecting your line feature, which is the canal, you can pause logging that feature, collect your customer service, which is a point feature, and then continue along the canal and finish your line feature. That's a time saver. And then, if you aren't able to do that, then you might be collecting 2 lines, which would create 2 features that could then be a little bit more timely to post-process. So that's just one kind of unique feature of the Trimble GPS unit that's helpful. And another one that I wanted to mention is the offset point feature. There is a laser built into the G07X that allows you to take offset point features. So for whatever reason, if an area is unsafe to access, you can stand in an area that is safe and then use the laser to offset the point. And we've found that very useful. Also, if there may be a point that doesn't get very good reception, satellite reception, potentially due to tree canopy, and you could stand in an area that does have a clear line of sight with the sky, and then offset that point to wherever your feature may be located. And that brings me along to another topic, just some collection challenges out in the field. You do want to consider where you're going to be collecting this data. For example, if you're up in Northern California, some of the state parks that we visited with a heavy tree canopy in the redwoods, you may not be able to get a satellite signal there. One trick that we did learn is that oftentimes, if you start the GPS in a location that has a clear line of sight of the sky, and then move into an area with heavier tree canopy, the likelihood that you will be able to accurately log features will increase, versus if you start the GPS under heavy tree canopy, you may not be able to get any reception whatsoever. And along those lines, it's just important for field crews to adapt to field conditions. So Scott mentioned those hard copy maps. Those can be really useful for taking notes, and you may come across certain features that need additional explanation. So having the hard copy maps is a perfect way to go about and record that information. You can see the photo in the lower left-hand corner. We typically had 2-man field crews. So one person would be on the GPS and the other taking notes and marking up the hard copy maps. We found that to be really efficient because you kind of get into a groove, and one person can become pretty quick in using the GPS, and then the other person can kind of create their methodology for note taking, and that allows to really maximize your efficiency. And another item that we found really beneficial is taking videos. So even when you take photos, it almost never fails that you forget to take a picture from that one particular vantage point that you need. So we also got into the habit of taking videos and then narrating those videos as we were collecting features as well. And that can be really beneficial. A couple other basic items that I just wanted to cover are to communicate with property owners in advance of fieldwork. It sounds really basic, but I've come across multiple scenarios where it's good to have a proper form of ID or credentials. If you do have a contract or business card, office contact, it really helps. It never fails that people are going to be curious about what you're doing, and having your safety equipment and just having proper credentials is helpful in that scenario. Access and safety concerns. So going out into the field, you're planning in the office, and sometimes you don't really think about what you're going to actually be encountering in the field. I've come across all of these scenarios: wild animals, ticks, poison oak, even pets. There was a circumstance where I was out in the field collecting information at a culvert, and there were 2 rattlesnakes. Luckily, it was a cold day, so they were sluggish, and I was kind of keeping an eye out, and I was aware, so nothing bad happened. But it's just important to go over these kinds of safety concerns with field crews so that they're just aware and that they're in the back of their mind when they're out in the field collecting this data. And then post data collection, specifically for field crews, if you're going to be out for multiple days, I do recommend backing up data daily. Sometimes when you're out in the field, the notes that you take may not be clear, or you may need to add additional detail. And if you go and review them the night after you've been out in the field, you'll probably remember and be able to strengthen those notes. But if you wait 2 or 3 weeks, there's a good chance that you're not going to remember. And also just save any photos or videos that you did take. And also review the data in your notes. Take an opportunity to look and see if there's anything missing. And if there's anything that you can't remember or that you feel like you need to revisit in the morning, you can prioritize that in the morning before moving on to another section and collecting additional data. And I'm going to go ahead and turn it over to Scott now to talk about post-processing data once you are back in the office.
All right, so when you get your data from the field crew and they come back with the GPS unit, it's really important to, as soon as possible, download that data, process it, then examine it. So you're going to be looking for certain things. You're going to look for missing data, make sure they got all the data you're expecting. I never really had a problem with missing data, but it's something you should look out for. Look for features that are just plotted in the wrong place. The only time we ran into that, it was in the redwoods. I mean, redwoods are really good at blocking the satellite signal, so sometimes we'd find features that are just in the wrong place, and then in GIS you can go back and correct it and say, okay, we know it should be closer to this. Obviously, we're not getting good elevation data from that. Check anything that's a text input, because typos happen. So just get in there, especially with you're using this really tiny screen and a stylus and trying to type out the whole alphabet there on a tiny screen. That's our field crews are actually really good at that, but just double check that. You'll also need to clean up any map buildings. Like I said before, map buildings, if they find a building out there, yeah, it's not going to look, the buildings will not be at right angles. So you probably want to go through and clean that up. And if the field crews walked lines, just because the data accuracy will drop off as they're moving around there, it's going to look like your field crew was drunk when they're walking some of these lines. Just really zigzaggy line. Obviously not drunk, but just bad data. Well, it's not even bad data. It's just not the most accurate there. You want to clean up these lines, get them to be smooth curves or straight lines. It should be pretty obvious what was going on, but you just need to clean that up. And then if you have field notes, if you're using that technique, you want to go over the field notes and make sure everything that's on the field notes gets into the GIS. And you do want to save these. We still refer to stuff we took years ago. So you want to save your field notes, make sure you got the date on them, where it was taken, and keep those in some sort of binder or folder. So they're really, really handy to have. If you're doing differential correction, this is how you can get really highly accurate GPS data. You combine your GPS data with a base station. You combine these together using this technique called differential correction. This gives you the half-inch accuracy if you've got the right data. But the base stations only hold that data for 2 weeks. So that's why you've got to process this stuff within 2 weeks. And also, if you run into problems and you need to talk to the field crews, well, everybody forgets something after, say, 2 weeks. So talk to the field crews if you have any questions there. And if you need them to change their technique, make sure they're getting this, or you don't want them collecting that, make sure you're talking to them. You really need to communicate with them. It's usually, it's always worked out really well for us. And yeah, photos. Just want to reiterate this. Having photos has answered so many questions for us. We don't need to go back out of the field, because you can just look at a photo and go, oh, there's the answer right there in that photo. Next slide. Just want to talk a little bit about updates here. And updates, actually, if you got to go out there, sometimes it can be kind of miserable. You got to go through this process of taking your desktop GIS information, loading it onto your data logger, going out to the field, having the field crews fill out new information or update the information. Then you got to download it again, and now you've got to merge it back into your GIS database using your desktop software. And that's all doable. It just can be time-consuming and a bit of a pain. So the next slide here, I want to show you a technique we came up that just sped things up. We just kind of bypassed the data logger all here. So we actually use printed maps for updates. And in this case, what we were doing was we needed to yearly go out and inspect drain inlets for sediment and trash. And instead of going out there with the data logger and going through the whole setup process there, just in the office, I just used labels to mark out using the unique ID there. This is one of the reasons unique IDs are so important. You can see like CC22, CC76, those are the unique IDs. And then there's all the information we have out there that we need, like pipe diameters, the height of debris, whether trash was visible there. And as the field crews would go through here, they just put a check marks there when they show that they've been there. And if there was any changes, they would just in red pen make any changes if there was the difference in the debris heights. And then they just brought those back to the office, and it was very quick. We just usually use a student to go through all this information and make any changes to the database. And this was fast and easy. And it only takes a few minutes to do this in the office and saves a lot of time, a lot of headache. And I just thought this was a nice technique that really worked out well for us. I think we're at the end here.
All right. Have a few minutes to go ahead and take questions.
Yeah, we have several questions, and I want to make sure we have time for all of them. As a quick reminder, please remember that we will be sending you a follow-up email with a link to the recording and also a link to our evaluation survey, which we'll also put in our chat right before the end of the webinar. I want to start by going back to the beginning. We had a couple questions that dealt with the smartphones and the smartphone connection. So the first question was, can you just quickly review the names of the different mobile apps that you had covered in the beginning? So maybe you could tab back to the slide.
Yeah.
Yeah, well, that was the CUPS mobile app. There's a popular one. Esri makes the collector app. And I don't know the names of the other commercial apps. We've looked at those in the past, but it's been a while. So we actually honestly don't remember some of the other apps out there. And there's more out there. I just put them in here just for review to show they're out there. But that's not what we use. Our expertise is on the using that the Trimble Geo7X.
Perfect. Yeah, we did have a question about the CUPS app and whether that was still in use. Do you happen to know if the EPA retired that one?
So I believe they aren't updating it. I have used CUPS, I believe, within the past year or so. I had success using it with an iOS platform. I don't believe the platform for Android is working correctly. Scott, do you have anything to add to that?
I tried for this to load the CUPS on Android. That's my phone I have, but it wasn't available, unfortunately.
Okay.
Apparently is out there for if you've got an Apple phone.
Okay, and that actually brings me to the next question about smartphones. Do you know if you can use any smartphone or whether it needs to be Apple, Android, or if there's a better one for data collection with the Trimble unit?
I think you can use just about any platform out there. I mean, if you're using these commercial apps, they're trying to sell you the service, so they're going to go out of their way to try and make sure it's available to you on any platform. Is what my experience has been. But that can obviously.
Just to clarify that question, did it say which cell phone with the Trimble GPS unit?
It says, do you need an iPhone for data collection or just an Android?
Oh, okay.
I've definitely seen them for Android.
Yeah, I think they're available.
Okay, great. And then moving on, you had covered cost estimates a little bit early on, Scott, but do you have a dollar estimate for the Trimble unit?
Oh gosh, it's in the thousands of dollars for, depends. There's different Trimble units out there. You can go, we went with the highest end one out there because we needed the what they call the I think it's called the centimeter edition. And so this was just the ballpark. I think it was 15,000 for everything, but this includes a lot of the other equipment. You know, so not cheap. Like I said, we're looking at a small car here.
Yeah, we can assume not cheap. I think that's a good.
Not cheap.
Nice,
that's why maybe the way to go. It's like,
yeah, you do have an
nice
opportunity
unit.
to rent some of these units as well. And in those, I don't have exact costs, but you know, if you were to rent for a day or two, or even over a weekend, it'd be, you know, significantly cheaper, a fraction of the cost. But it's going to depend on where you're renting from, what that cost is going to be.
I'm not getting any money from Trimble though, so don't worry about that. I'm not trying to sell it, but we did like the units. But yeah, that price tag may just stop you.
Okay, and then next is the questions are dealing with the data dictionary. Is there a limit on how many data fields can go into the data dictionary, or any limitations on the type of amount of data you can collect for each point that you would put into the data dictionary?
I'm not aware of any limitations. We put a lot of different fields in there because we're trying to collect so much data, and we're actually, gosh, even just to make it simple in the field, like for pipes and canals, we actually combine that into one field, which is the first thing we would ask: is this a pipe or is this a canal? Then we'd send you off kind of in a branching directions using the data dictionary. So you can get a lot of fields and data into there, and how much you can store basically depends on the how much memory is in the Trimble, and I don't think you're going to have a problem storing a lot of information in there.
Okay, and similar to that, sorry, in the same vein of that, we had questions about, you know, the data, the sizes of photos and the amount of storage you can use for potentially videos as well. Do you know of any limitations on photo size or file storage?
Photo size is just the photo size you get there. The video that we're taking, they were using their personal phones to take videos. The G07, as far as I know, doesn't have video capability.
No video capability. And then, yeah, but we would always take supplemental photos and videos just with our personal cell phones. And Scott, I believe, yeah, I mean, there's no reason with the photos too, you can add after the fact the photos taken with a cell phone into your GIS database.
Yeah, you can do that. It's nice that the photos with the G07 automatically are in the database. So when you click on that feature, you can automatically see the photos. If the field crews are taking photos or video with their phones, you can use the latitude and longitude that are embedded in those photos to bring them in, but they're not tied in directly. So they're useful, but I like to use the photos you get with the G07, but obviously, yeah, no video. So, and you got to store those, like you got videos in a separate folder. So it's a little more data management, but it's still good to have.
Great. Okay, and then we had a bunch of questions come in quite sort of right in the last 5 minutes. So one was just a clarifying question. Can you explain what you mean by base station?
Oh, base station. This is, well, for differential correction. What's going on is that if you were just to hold your GPS units out there in the field just perfectly still, just due to the nature of the GPS satellites passing overhead and disappearing, it would actually look like your unit is wandering around a little bit. So the base stations are sitting there, they're firmly attached to the ground, they're spread out throughout the United States and actually throughout the world. And they just sit there and look for that wander that just happens with the GPS signal. And then when you combine your signal to a nearby base station, it can account for the wandering that's happening to the signal from the GPS units. And it says, okay, it wandered 2 feet to the north at this time. It'll correct your GPS unit by the 2 feet instead of 2 feet to the south to correct for that. And that gives you a really highly accurate measurements when you combine this all together. That's a really simplified version of it, but that's basically what's happening with the base stations.
Got it. Okay, great. And then the next question, and again, these all kind of came in close to the end. So can you transfer data from something like Google Maps or Google Earth, or does that integrate into any of these applications?
What we do is like from Google Maps or Google Earth, you can get that information in there. You can, as a background, put in aerial imagery. So if you're going to be in a certain area, you can actually load aerial imagery into the background of the GEO7X. So as field crews are walking around, you can see imagery around you. We didn't do that too much just because it took a lot, and it took a lot of the storage space on these units. So we didn't tend to do that. You can bring it in if you want to. You can go into Google Earth and make shapes, say outline buildings there. You'd have to, actually, you could theoretically save that. I believe Google Earth actually lets you save that as a shapefile, which you then could import that directly into the GEO7X, say if you want to do buildings like that. Yeah,
okay. So it'll kind of integrate across.
GIS or ArcMap would be better to do it, but you can do it if you want to with maps.
Okay.
And if you're using it to get your bearings, that's where a hard copy map could also be useful too. And then you still have that ability to reference that, and you aren't taking up space on your GPS unit.
Okay, and then I just want to, at this point, let everyone know. So we do have a good amount of questions. I think Scott and John, if you're okay, maybe we can go 1 or 2 minutes over to cover them. But for folks who need to jump off right at 2, I will put a link to our survey into the chat right now. And you can feel free to fill that out. Folks who'd like to stay to hear the rest of the questions, we'll just go only a couple minutes over. Okay, so the next question is, can you export from the handheld to utility software or Excel directly from the handheld?
Oh, directly to Excel?
Yeah, that's the question.
It does have a lot of export options. It's really gonna want to go to a like a shapefile or GIS-based information. But all those that data actually, when you look at it, you gotta do one more step to export it. You'd have to go into some other software to export into Excel. You can just open these files right up in QGIS. You'll see a table there. You just export that out, save that as an Excel file or a CSV file. And Excel could be that. So there'd be one step there. It's a really simple step that minimal training could get you to do that.
That makes sense. Have you had any success with different types of dongles to increase the cell phone accuracy to sub-meter?
Yeah, I've never tried that. I've heard of people doing that, but yeah, I don't know. That's a possibility, but yeah, I don't have any experience with that, unfortunately.
Okay, and then finally, what do you think of the R1 GNSS Trimble, if you're familiar with that version?
Oh, I don't know that one. That might be, I don't know if that's a newer one or an earlier one. Yeah, unfortunately, I don't know that. I know there are other Trimble units out there. Some of them are less expensive, but many of them are actually using the same software and using the TerraSync software, which actually I was pleasantly surprised with that how well it works. So if it's using that TerraSync, it's the Trimble unit. I'm saying it would probably work very similar to what we use. It might have less accuracy, but you might be able to save a lot of money on the unit cost.
Okay, and then this is another one about data linkages. Can you link PDFs to a collected feature?
Oh, you can. You'd have to do that in back in the office, obviously. But yeah, you can link just about any file you want to a feature. You can do that.
Okay.
So if you click on that feature, yeah, then a PDF will pop up.
Perfect. And that goes hand in hand with all that other information and videos you might have collected along the way too. So Okay. Do you ever mark the spot with some kind of feature so if someone comes back, they can be in the exact same location? I guess this is a data collection question.
Oh, like, yeah, like a benchmark or a survey marker
Yeah.
or a flag. We've never had to do that. We've just, yeah, that's something
Yeah,
you could
and
do. We've never done that.
the specification is like if you're in an open field or something.
Oh, so they want this. There's always something that we're interested in, whether it's a drain inlet or a manhole cover or the change in size of a ditch or a ditch transitions to a pipe. We're always right at something that's obvious in the field that you would go to. We've never had like in the middle of the field we'd have to go back to. So we've never run into that. But yeah, you could put a marker in there. It's just you have to worry about people taking your markers, especially if it's in publicly accessible areas. Then
Oh
you
yeah.
might have.
Yep.
Or they like to move them.
Yeah.
Okay. And then do you know anything about the position or elevation accuracy?
Oh, like I said, well, the better your positional horizontal accuracy is, the better your elevation accuracy is going to be. And what I can tell you is that the more money you spend, the better it's going to get. That's why the unit we did was so horrendously expensive, is for that accuracy. It's it just costs more there. Like I said, if you don't care too much about your accuracy, cell phones can get you within 10 feet or less, and for a lot of applications, that's fine. But for us, yeah, since we're trying modeling and really needed to nail down these positions of these inlets and pipes, we needed the high accuracy.
Great. Well, at this time, I think we've covered pretty much everything, and we're only 2 minutes over. So at this point, I guess I'd like to turn it back to both of you for any closing comments.
Just thank you, Tess, for organizing this. And I just wanted to, again, put up a link. We have our contact information as well. If you have any additional questions or would like to contact us, please feel free to do so. And thank you all for taking the time to join us on this webinar today.
Awesome. Thank you so much to both of you. I hope everyone enjoys the rest of their day. And again, questions, please let us know. We also have that technical assistance form available, so fill that out if you're a small system that would like a little more information or help doing this. We'd be glad to set something up for you. All right. Bye,
Thanks,
everyone.
everybody.
Take care. Thank you.